today again we are coming with another session with inverse trigonometric functions. We are going to discuss about a few very important properties, and few of them the proof also we are going to discuss. Okay, so let me write down the properties. There are a set of properties. I am just numbering them as 1, 2, 3, 4. Sine inverse of minus x is minus sine inverse of x. Cos inverse of minus x is pi minus cos inverse of x. These both are true for all x belonging to minus 1 to 1. Next is tan inverse of minus x is minus of tan inverse of x. Cot inverse of minus x is pi minus cot inverse of x. And this both result is true for all real numbers. And then lastly, cosec inverse of minus x is minus cosec inverse of x. And sec inverse of minus x is pi minus sec inverse of x, and both these results are true for all modulus of x greater than or equal to 1. Let's set 1. We'll try to prove these two results, and the rest of the results you can try of your own. Okay, so I'm proving that. Let sine inverse of minus x equal to theta, where theta is lying between the range of sine inverse, that is minus pi by 2 to pi by 2. So obviously sine theta will be equal to minus x. Okay, now look, theta is lying between minus pi by 2 to pi by 2, so definitely x will lie between minus 1 and 1, and so minus x will lie between minus 1 and 1, and minus theta also will lie between minus pi by 2 to pi by 2. So this here we can take sine inverse on both the sides, that is, let me take first sine theta only. Sine inverse of minus x. Sine inverse of minus x. X will be equal to minus sine theta. It can be written as sine of minus theta. So minus theta will be equal to sine inverse of x. So theta will be equal to minus sine inverse of x. So theta was sine inverse of minus x. So it is minus sine inverse of x. Okay, now we'll go for the second one, that is that cos inverse of minus x. So we'll again start like this. Let cos inverse of minus x equal to theta. Theta is lying between the principal filograms of cos, that is 0 to pi. So minus x will be equal to cos theta. Now x is lying between minus 1 to 1. Minus cos theta. We need, before cos inverse of x, we need minus x. So minus x will be equal to cos theta, that only. So cos inverse, so we need to know where minus x lies. Minus x is lying between minus 1 to 1 only. Minus x is theta is nothing but cos inverse of minus x. Cos inverse of minus x will be equal to pi minus cos inverse of x. Now here this step, we can bring this cos this side to make cos inverse, because pi minus theta is lying between the principal filigrams of cos inverse. This is very important step. Again, similarly we can go for the rest of the properties. So I'll advise you to try yourself to prove this. Okay, you can take help of this too. Okay, we'll go for the second set of property, that is for all x belonging to minus 1 to 1, tan inverse of x plus cot inverse of x is equal to pi by 2. For all x belonging to the real numbers, then sec inverse of x plus cosec inverse of x is equal to pi by 2 for all modulus of x greater than or equal to 1. We'll try to prove the first one. So x will be equal to sin theta. Now theta is lying within minus pi by 2 to pi by 2. Sin theta can be written as cos pi by 2 minus theta. But before I bring this cos to this side, cos inverse, I have to check whether pi by 2 minus theta, where it lies. Okay, so we'll check minus theta is lying within minus pi by 2 to pi by 2. I need pi by 2 minus theta, so we'll add pi by 2 to get this. So cos can be brought here. Cos inverse of x will be equal to pi by 2 minus theta. So and that's the result. Theta plus cos inverse of x equal to pi by 2. Theta was sin inverse of x to pi by 2. Similarly, the other two results can be proved. Okay, we'll go for the third set of properties. So this three property, out of this I'll try to prove first and the third. Okay. So let cosec inverse of x equal to theta. So x equal to cosec theta. So x will be equal to 1 by sin theta. So sin theta will be equal to 1 by x. So theta will be equal to sin inverse of 1 by x. Not a problem here. Okay, this proves this problem. We're going to prove this tan inverse 1 by x equal to cot inverse of x. So let cos inverse of x equal to theta, so x equal to cot theta. So tan theta will be equal to 1 by x. Now before I create tan inverse of x, I have to check where theta lies. Theta is lying in 0 to pi. No. Tan inverse x without a tan inverse x will give me two different values in this interval. Okay, so when theta is lying between 0 to pi by 2, then I will get another value, different value, and when theta will lie in this, then also I will get a different value. For this interval we get theta itself, and for this interval we get minus pi plus theta. Okay, so the inverse function which will be created from here will have two values. In fact, there will be two values. So theta will have two values: tan inverse of x, tan inverse of 1 by x will be equal to theta if theta is lying between 0 to pi by 2, and will be equal to minus pi plus theta if theta is lying between pi by 2 to pi. That is equal to cot inverse of x if x is greater than 0. Theta is lying here means x will be positive, and minus pi plus cot inverse of x if x is less than 0. Theta is lying here means x will be negative. So this is how the second result can be obtained. Sorry, third result. So that second result is left as an exercise to be done by you. So I am going for the next set of property. This says sin inverse of x plus sin inverse of y is equal to, again it will have two values: sin inverse of x root over 1 minus y square volume comma plus y root over 1 minus x square, and pi minus sin inverse of x root over 1 minus y square plus y root over 1 minus x square. The next property 4 is this: sin inverse of x plus sin inverse of y is this. This comes with a condition: x comma y greater than equal to 0, x square plus y square is less than equal to 1. And here x comma y greater than equal to 0, x square plus y square is greater than 1. Okay, so we'll try to prove this. Proof. Let sin inverse of x equal to theta and sin inverse of y equal to pi, so that theta is lying between, generally it is lying between minus pi by 2 to pi by 2. But since we have taken x and y are positive, so it will lie between 0 to pi by 2 instead. Both included. And similarly phi is also lying between 0 to pi by 2. So that if I find theta plus phi where it lies, simply add to get that theta plus phi is lying between 0 to pi. Again, we are working in sine inverse, and at some point theta plus phi sine inverse will come. So it is coming in 0 to pi. Again, 0 to pi, sine inverse x will have two values. So both the values we have to consider. Okay then. Now, sine of theta plus phi, sine theta sine phi plus sine theta cos phi, plus cos theta sine phi. We know this. So sine theta is x, cos phi is root over 1 minus sine square phi, that is 1 minus pi square. Cos theta is root over 1 minus x square, and sine phi is y root over 1 minus x square. Okay, now before I go for taking sine inverse, we have to make sure that theta plus phi is lying in principal value branch of sine inverse, but it is not. So again, this will give me two values. When theta plus phi is lying between 0 to pi by 2, then sine inverse of sine of theta plus phi, sine inverse of sine of theta plus phi will give me theta plus phi. Okay, and when theta plus phi is lying between pi by 2 to pi, sine inverse of sine of theta plus phi will give me pi minus theta plus phi. Please understand that day we have discussed about the graph, if you could remember. Sine inverse of sine theta is theta in this interval minus pi by 2 to pi by 2, and this one is y equal to pi minus x, is y equal to x. This is how it works. So when theta plus phi is like pi by 2 to pi, then sine inverse of sine of theta plus phi will give you pi minus x. This one I have drawn for x, sine inverse of sine x graph. So when it will be theta plus pi, and the same thing will work, y equal to pi minus theta plus pi. Okay, so we have used this. Okay, therefore, from here, if we will take sine inverse on both the sides, so we get theta plus pi will have two values. Okay, one for this interval, one for this interval. So what is that? One is theta plus pi itself. Let's write like this: sine inverse of sine of theta plus phi will be equal to sine inverse, theta plus phi. Otherwise I'll get pi minus theta plus phi when theta is inverse. This way also going to take sine inverse. Sorry. Okay, so this one we are going to use here now. So both sides sine inverse. Here sine inverse, theta plus phi will remain, two values, and here also sine inverse will come. So ultimately therefore theta plus phi will give me on the left hand side theta plus phi, sine inverse of theta plus phi. So we'll have two values. One is theta plus sine inverse of this, sine inverse of x root over 1 minus y squared plus y root over 1 minus x squared. Okay, and the other value is minus pi minus theta plus phi, that is pi minus this x root over 1 sine inverse of sorry. I hope you have understood. Now, this is not yet over actually, because we have to look for these inequalities also. This has to be true for those inequality also. So we have to prove along with this result the inequality also. So we'll go for the inequalities. I'm wrapping this up. So first, theta plus phi is like less than equal to pi by 2. Theta is sine inverse of x. This one is sine inverse of y, less than equal to pi by 2. So I'll get sine inverse of x less than equal to pi by 2 minus sine inverse of y, which is nothing but cos inverse of y. So ultimately I'll get sine inverse of x less than equal to cos inverse of y can be written as sine inverse of root over 1 minus y squared. Sine can be taken both sides again, so I'll get x less than equal to root over 1 minus y squared. Squaring both sides, I'll get x squared plus y squared less than equal to 1. So this completes this result. Okay, sine inverse of x plus sine inverse of y, sine inverse of this. If x and y are positive, eliminate x squared plus y squared less than equal to 1. And similarly, if I'll consider theta plus phi greater than equal to pi by 2, I'll reach at x squared plus y squared not equal greater than 1. Okay, so same way we can do the next two property which are coming up. Property 4. One was this, the second one is cos inverse of x plus cos inverse of y is equal to, it will have only one value, cos inverse of xy minus root over 1 minus x squared into root over 1 minus y squared, where x and y are positive, both are positive. Okay, this is the result for cos inverse, and the third one is for tan inverse. Tan inverse of x plus tan inverse of y. It will have two values, tan inverse of x plus y upon 1 minus xy. It comes with some condition, x, y both are positive, and xy less than 1. And y plus tan inverse of x plus y upon 1 minus xy. X, y both are positive, but their product is greater than 1. Again, this also can be proved. So let me go for this. Let tan inverse of x equal to theta, tan inverse of y equal to phi, theta and phi as x and y are positive can be taken as theta comma phi both belonging to 0 to pi by 2 open interval, 0 closed, pi by 2 open. Okay, so theta plus phi, because this is what we are looking for. Theta plus phi definitely will be lying between 0 to pi. Again, tan inverse x, again we will have the same problem here, 0 to pi, again it is coming. So theta plus phi will have different values in different intervals. Somewhere we have to go for tan inverse of tan x. So tan inverse of tan theta, again it will be, the graph is something like this. This one will come y equal to x, and this one will come y plus x, y minus x. So that if we put y equal to 0, we'll get x equal to pi, correct? Okay, so what we'll do, we'll break it into two parts. When theta plus phi is lying between 0 to pi by 2. Then tan theta plus phi will be of course tan theta tan a plus tan b. That formula we will apply, 1 minus tan theta tan phi. Tan theta is nothing but x plus y by 1 minus xy. Now before I go for tan inverse, now theta plus phi we have to consider. Theta plus phi we have considered to be between 0 to pi by 2, which is a subset of the principal value terms of tan inverse, so it can be done. So theta plus phi, simply tan inverse will be created there, tan inverse of x plus y upon 1 minus xy. Okay, and theta plus phi is nothing but this tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus x. Now, from here to here we have done 0 to pi by 2. Now if it lies in this interval, the value of theta plus phi will change. Okay, so for that interval also we have to discuss. But before that, this again coming with this inequality, let me talk about the inequality here itself for this case. Here theta plus phi we are taking less than pi by 2. So theta plus phi is less than pi by 2. Less than or equal to pi by 2. No problem. So theta will be tan inverse of x less than equal to pi by 2 minus phi. Phi is cot inverse of x. So which is nothing but tan inverse of y, sorry, phi, which is nothing but cot inverse of y. So tan inverse of x less than equal to cot inverse of y can be written as tan inverse of 1 by y. So that we get xy less than equal to 1. Less than equal to 1. Equal to 1 become tan inverse of infinity pi by 2. Okay, no problem. Okay, so this is the inequality along with this result. X and y are both positive, and this is what it will happen. Now we have to discuss the same result for this interval when theta plus phi will lie between pi by 2 to pi. So we'll go for that. When theta plus phi is lying between pi by 2 and pi, then what will happen is this: tan of theta plus phi will be equal to this right hand side, it will come the same, tan tan of theta plus phi, tan theta plus tan phi by 1 minus tan theta tan phi. So this one will come ultimately x plus y upon 1 minus xy. Now tan inverse, because I am looking for the value of theta plus phi, so we have to take tan inverse on both the sides. So tan inverse, the moment I take tan inverse, as it is not lying in the principal value runs, so that value will give me y equal to pi minus x. So ultimately that value of x will get value of x we are going to get as y plus x, y minus x only. Okay, no problem. Y to the y minus x, positive slope, and y equal to 0 is equal to minus pi plus x minus pi plus x. So here tan inverse of tan theta will give me minus pi plus theta plus phi. So theta plus phi will be equal to, and this side, the moment I am taking tan inverse, this way also tan inverse will come in this step. So pi plus tan inverse of x plus y 1 minus xy. Okay. Look here, the moment I am taking tan inverse here, so I am going to get minus pi plus x, this minus pi plus theta. Tan inverse both sides it will take, so at this side it will become tan inverse of x plus y upon 1 minus xy. Okay, and the inequality can be worked just like the previous case. I'm just showing it again. Theta plus phi is greater than pi by 2 this time. So tan inverse of x plus tan inverse of y greater than pi by 2. Tan inverse of x greater than pi by 2 minus tan inverse of y, that is cot inverse of y. Cot inverse of y can be written as tan inverse of 1 by y. Tan both sides if we take tan, it will become xy greater than 1. So this is how this result came into exist. I hope you have understood. So let me go for some questions based on these properties. Okay. Evaluate. Very easy question I am taking. Sine of cot inverse of x. Number 2. Tan of cos inverse of 1 by 5 root 2 minus sine inverse of 4 by root 17. Let me take one more question. Tan of sine of tan inverse of cos of cot inverse of sec of sine inverse of a, where a is belonging to 0 to 1. So let me take these questions one by one. And here we are going to learn a very good very good, what we'll call it, very good trick we are going to learn while solving all these three questions. Okay, see, sine of cot inverse of x. So my aim will be to get here one sine inverse. So all I need to all I need, how do I convert cot inverse to sine inverse? So this question has to be done like this. Cot inverse of x, we'll take cot inverse of x as theta, so that x equal to cot theta. So we'll take the help of Pythagoras theorem, because this all are nothing but the angles, trigonometric angles of trigonometric functions. So they are definitely coming out of a right angle triangle. So we'll take this one of the acute angle as theta. So x equal to cot theta means cot theta is, we know that this is the ratio between base and perpendicular. So this one is x, this one is 1. I'm just taking the numeric values. The ratio already I have declared that it is the ratio. So definitely this one will become sum of the squares of the other two sides, that is 1 plus x squared. Okay, so now from here I'll find out the desired one. What I mean, cot inverse I'm looking for changing into sine inverse. So if I get here sine theta, then I can take the sine, ultimately I will get the inverse function of x, sine inverse of x, that is. So cot theta, from here I will try to find out sine theta. Sine theta is for perpendicular upon hypotenuse. So 1 by cot of, therefore sine theta is equal to 1 upon root over 1 plus x. So theta will be equal to sine inverse of 1 by root over 1 plus x. Now look, theta we have started with cot inverse of x, and the same theta we are getting as sine inverse of 1 by root over 1 plus x square. So this is what we are looking for. So the question was this. So sine of cot inverse of x will be equal to now sine of sine inverse of 1 by root over 1 plus x square. So using that property, we'll get this one to be 1 by root over 1 plus x square. As simple as that. Okay, we'll go for the next question. Tan of cos inverse and sine inverse. So these are nothing but angles. So if I consider this one to be theta and this one to be phi, ultimately the question is tan of theta minus phi, tan of a minus b. That is what the question is asking us. But those angles are inverse trigonometric functions. How do I do it? Okay, let me take this one as theta, and this one is phi. Cos inverse of 1/5 root 2 to be equal to theta, and sine inverse of 4 by root 17 to be equal to phi. Let me convert into tan. Cos theta will be equal to 1/5 root 2. So again we'll take one right angle triangle. Theta. Cos theta equal to 1/5 root 2 means base by hypotenuse is this. So how do I get it? Square it minus this, then square root. So here square is 25 into 50 minus 1, that is 49, square root is 7. So I need 10, therefore tan theta from here is perpendicular by base 7, perpendicular by base. So from here also I'll find out tan phi. Sine phi equal to 4 by root 70. I'll make one right angle triangle. Phi is 4 by root 17, that is perpendicular is 4, hypotenuse is root 17, or like it square minus this square, 17 minus 4 square 16 is 1, so this is 1. I'll find out tan phi. Tan phi is perpendicular by base, that is 4. Alright then. So I'll get theta equal to tan inverse of 7. And from here I'll get phi equal to tan inverse of 4. Again, so the question looks like now this tan into 7 minus tan inverse of 4. So tan inverse of x minus tan inverse of y formula. That is tan inverse x minus y by 1 plus xy. So this one will give us tan inverse of 3 by 29. So this formula is true for all real numbers, so 3 by 29 is the answer.